welcome everybody. It is office hours time again. In fact, I should say, welcome to the glamorous evening life of an Oracle professional. I've just spent the last 20 minutes trying to get the dishes done before I start office hours. That's how life works in the remote part of the world when you give your office hours at 9 p.m. at night. Hopefully you can hear me. Hopefully you can see me. Sing out if you can't. We've got some good fun things to cover today. I alluded to a few of them on Twitter. But without further ado, let's jump in, share the screen, and let's get going. As always, at any time, you can sing out in the chat with any questions or queries, and I'll either answer them live or we'll take them offline and see what we can do. But yeah, so obviously it's always meant to be fun and interactive and very, very casual. That's the idea here. Okay, let me share my screen and okay, so hopefully you can see the slides, etc. So getting in touch is easy. You can simply go to linktree/Connor and it simply brings up a panel showing you all the different ways of getting in touch with me. Probably the easiest way for casual conversation is Twitter because I live there probably the most often, but YouTube channel if you're that way inclined, SlideShare, blog, etc., etc. Notice there's a new little thing there saying podcast. I'll be putting another episode in a few days' time, but yeah, try roll out about one per month. Thank you for those who have been giving very constructive and, in the main, positive feedback on the podcast. If you're new to office hours, I always say do not adjust your set. The slide content will be down toward the bottom left because later when we turn this into a YouTube video, my ugly mugshot will be at the top right, hopefully providing a bit of balance. Quality content, not so quality facial features. So a few bits and pieces to get us going. Number one is the next conference event I'll be doing is for the Romanian user group. That's coming up on May 25th, 26th. So hopefully you can join that, register that. And there's a whole stack of us, I think, across the 2 days getting involved. So please sign up for that. It's a bit of a personal bugbear because literally I was almost on a flight to Romania from the Netherlands when COVID back in March 2020 came rolling through the world and I had to divert that plane from Romania back to Australia. So I missed going to Romania by this much. So it constantly saddens me that I haven't been able to get back there. Maybe next year. After that, I've got Kscope coming up. Kscope also a virtual event. I think they've announced that next year's Kscope will be back physical location. I hope so. But yes, I'll be speaking at Kscope in July as well. Couple of little homegrown biases here. Please go to ausl.org.au. One of the joys of being in a virtual world is that you can attend events that you would probably not ever attend in person if you don't live in Australia. So we have this national webinar series going on. Please support the Australian user group. In case you've been living on another planet, last week we ran the next database focused event of the Developer Live series. We run something every month inside Oracle. We ran a database one last year. It's rolled back again this year to run the next database event. The good thing is, just like office hours, we capture them all and we keep them all online. So you can simply go to that link and replay all of the videos. Lots of goodies there. I did a talk on physical design. And one of the things I thought I'd shout out about what we did with these last Developer Live things is rather than just having content, we had half content, half hands-on lab. And to use that, we use this thing called Live Labs that has been launched now for about 6 months. If you haven't seen or heard of it before, literally we just have dozens and dozens of hands-on labs that are literally just sitting there and they walk you through using our technology on the Oracle Cloud. But you can also run that on your own database. A lot of these things are really just effectively a list of workshops, scripts, etc., that you can download, run, cut and paste, etc. So they're very much tailored to be able to run both either on cloud or on premise as well. They are hundreds of workshops there on how to get introduced to things like Oracle Cloud if you're fairly new to cloud. And probably the big one is it's all free. There's no single sign-on. There's no nothing. It literally is just an Apex app. You go there and you can do any single lab that's on there today. So it's shout out to Kay Malcolm, who I think drove this. But yeah, it's a fantastic facility. Think of it like, you know, Oracle Learning Library on steroids. And yeah, it's all free, all just sitting there all the time. You can take them at your leisure. Last month, I said we were so close to having 500 office hours sessions completed, and I'm pleased to say that as of this afternoon, we got 514 publicly completed office hours sessions. So thank you very much for your support. Let's charge on to 1,000, hopefully. So one thing I will say is, as I've always said with office hours sessions, in these sessions, the content is loosely driven by the audience in the sense that questions come in either via the office hours registration page or often just via Twitter or direct email, and I try and answer those questions. So the audience drives the content, but obviously it's a global audience. If you want a session dedicated for topics at your customer workplace, your IT department, please reach out to anyone in the office hours team. And yeah, we can hopefully tailor an office hours session that is literally private just to you. The best example of that is we use office hours extensively internally here at Oracle. We actually have private, Oracle internally sessions as well. So the office hours infrastructure lets you run private events just for your organization. As I've been saying every single month, it used to be I used to put a picture of the globe. I've narrowed the focus. So many great friends in India who are just absolutely in dire straits at the moment. So wherever you can help, if you can, please help out our wonderful Indian community. And I should say, just in the last few days, wherever you are in the world, if you're in any kind of troublesome times, heart goes out to you. A lot of people around the world at various places I've visited currently in periods of unrest. I hope we all get to see each other soon, safely and healthy soon. One thing I will say is I got my first jab last week. So, if you want our communities to be back, please get vaccinated. 3 more months, and then I get vaccinated again, and then I'm 100%. So I'm an AstraZeneca person, not by choice. That's just what the government gave me. So what are we going to cover this session? How are we going? We're getting through time. So last month, we didn't get to the parallelism disables index use, a slow recycle bin. That's a fun one. We'll talk about Autoextend, how to trace a single SQL statement in your database, and the difficulties and challenges of moving away from util file dir parameter, which was, and we'll talk about a customer issue with that. And I'm pretty, I always say, I don't know, I'm relatively confident that we should be able to get through them. So let's jump straight into it. Parallel operations versus an index. And here's the question that came in. I have a query that is using an index scan, and presumably this person likes having an index scan, but I would like to speed it up. When I add the parallel hint, it disables index use entirely. And the question is, why would parallel do that? Let's answer it with a very powerful statement first, but obviously I'll then try to justify this to you. Parallel operations do not affect index usage in any way, shape, or form. You can do parallel operations with an index. You can do parallel operations without an index. But what parallel hints do, or parallel enabled at the session level do, is it impacts the costing of queries. And the moment you can change the cost of a query, that can change the execution plan that comes out of that query. So I thought, let's have a little demo to show you how parallel hints can impact costing and therefore dramatically change execution plans. One would imagine, hopefully, for the better most of the time. Let's do a new share. So I'm going to create a table. It's a copy of DBA objects plus a few more rows in there just to put a bit of a bias in one of the columns, just to effectively, I'm going to create a histogram to demonstrate my point here. I'm going to create an index on this column called col, which was originally the owner column. So it's all the distinct owners from DBA object plus a nice heavy bias toward the value of system. Then I'm going to gather optimizer stats, and you can see there I've done for all column size 255, which will get me a nice healthy histogram on all the columns, but in particular my column called col, and we're getting a histogram of the different owners. Mental note, let me talk about in another office hours session why you should always use 255 or auto and never anything smaller when you come to gather histograms, but that's for another office hours session. Let's do a simple explain plan for select star from T with a column equals system. We print out the execution plan, and we can see we're at the opening state that our original poster came in with. I've got a query, select star from T where col equals system, and it's using an index range scan. Simple. Let's now add a parallel hint. So I'm happy with my index range scan, but I'd like it to be faster. So I throw a parallel hint in there to hopefully do 2 parallel index range scans. And as we can see, adding the parallel hint has ditched the index plan. It's actually come up with table access full now and our typical PX style operations inside our execution plan. And as you can see, this is effectively the motivation, I'd imagine, for the question. I added the parallel hint, my index scan disappeared. Does parallel disable index? Let's proceed onwards. Let's now do a full scan of this table. So let's take the index out, but also take the parallel out as well, and check out the cost. The cost says 545. Let's now continue on. Let's now do an index cost adjustment. I'm going to blow out my index costs now to even make it more expensive to actually use an index. And as you can see, the database has said, look, forget the index now. Full table scans are much, much cheaper than an index scan. This is artificial because I've told the optimizer to deliberately double the cost of an index. And when it was looking at the index range plan, it said, well, rather than being whatever its original cost was, it's now double that, and therefore 545 is a little bit lower. So you can see that the database, even without parallel, will toggle between index and full table scans simply based on cost. So for example, here I can do the opposite. Just to prove that parallel does not disable index use, I'm going to take the index and make them 1/100th as expensive. So I'm actually now telling the optimizer, look, indexes are just insanely cheap. And I'll put a parallel hint on there. And there we go. It said, your indexes are so good, I'm not going to use your parallel hint. Why would I bother? Because simply doing an index range scan is literally a cost of 1. It's infinitely quick because I've deliberately, manipulated the optimizer calculation by making indexes insanely cheap. So it actually works in all ways. Parallel may turn off index use. In this case, parallel was simply ignored because index use looks so ridiculously impressive. Let's go back to our standard select col. You can see here the reason we went for an index range scan originally was we said the cost was 37. That's our original cost. If I say, let's do a parallel index, what will the database do? I've said, look, I want to not do parallel full table scan. I want to do parallel index instead. And once again, it said, look, I'm just going to ignore that because the concept of doing a parallel index range scan doesn't actually exist in the Oracle database because it really makes no sense unless that index is partitioned, because then each partition of an index can be allocated to a particular parallel worker thread. I used to say slave, but you can't say that anymore. Now it's worker thread. One place where you can get benefit from both parallel and indexing on a non-partition table is if you tell a database, I want to do an indexed fast full scan, because that is equivalent to a multi-block read, like a full table scan, but on a index structure. So hopefully this will tell me, yep. So in this case, it actually said, I'm gonna do an index fast full scan, and that I can do in parallel because I can do multi-block reads, even though this index is not partitioned. So hopefully that explains to our poster here that the concept of parallel turning off indexes is not true. What parallel does do is manipulate the costing decisions made by the optimizer. And then once those costing decisions have been altered, the database does what it always does. It lines up the possible plans and says, which one do I think is the cheapest and therefore the fastest, and chooses that one. So feel free to keep using those parallel hints if you want to get parallel operations, but don't be dismayed. It's actually an intelligent decision by the database to say, well, in this particular case, it's better off to actually go with a full table scan. Hopefully that answers that question. Just on the topic of adding parallel hints, because one of the things I do see, especially in environments where we have, what's the term? Citizen developers, where we have, for example, business intelligence folk or data analysts who are SQL savvy, but perhaps not Oracle database internal savvy. The most common thing you'll see is, I ran a query, it's not running as fast as I like, let's bang a parallel hint on there, and hey presto, it might run better. Which is probably going to be true, because what you're simply doing is saying, let's just chew up as much server resource as possible. My general rule for approaching SQL tuning is I'll do everything I can before using Parallel to see if I can make a SQL statement faster. And then if I get to the point where that's as fast as I can get it and I still need to be quicker, then I'll consider using Parallel. Because if I take Parallel as being last, that's the what we call the Kiwi approach, the killing it with iron. So I prefer to let's see what other tuning opportunities are there first, and once I've exhausted all of those, change the design, adding indexes, removing indexes, changing the query, etc. Once I've come to an equilibrium or a steady state, then if I need to go better, then I'll maybe engage some parallel operations as well. That's my general rule. Hopefully that's useful. Quick drink of water. Question. Can you not allow users to use the parallel hint? Certain users rather. That's a very barbed question. Rachel, it sounds like you've got a particular set of users in mind. Yes, you can, but not inherently through the SQL engine. You can use Resource Manager. And so you can put certain users into a particular consumer group. And those consumer groups, one of the limitations you can do in a Resource Manager plan is the degree of parallelism they're allowed to have. And so in that case, you could say, okay, take a particular user, put them in a particular consumer group, and doesn't matter what they do, they'll only get a parallel degree of X, whatever you set that limit to be. Might be able to be done with lockdown profiles as well. I haven't explored that, but certainly Resource Manager is your friend there. One of the things I've done on a data warehouse that for a client we worked with a while ago was we actually dynamically switched consumer groups. So for day-to-day operations, we would let people, they would be prohibited from doing too excessively long queries, and they weren't allowed to use parallel. But if they submitted queries through effectively a warehouse reporting facility, then we would dynamically flip them into a more powerful consumer group to let them exploit more server facilities. That also let us use parallel statement queuing because we knew that all the parallel operations were coming from a particular spot. So hopefully that helps answer your question. Part 2, the slow recycle bin. Let's talk about the slow recycle bin. This is the question that came in. We never disabled the recycle bin feature on our database because by default the recycle bin becomes activated. And since we originally built the system with lots of free space, over the years our recycle bin has grown and purged DBA recycle bin seems to hang. How can we reclaim the space? So there's a lot going on there, a lot to unpack. So let's dig into a few parts of that statement and then we'll do a demo to see what's going on. In fact, we won't do a demo because when I was exploring doing a live demo with this earlier this afternoon, it took so long that I thought I won't subject that to you. So I'll just put some screenshots in of the demo that we did. So this is what I would normally say to a question something like this. When someone says, I've got stuff in my recycle bin, how do I get rid of it, etc., I simply say it's not an issue. Now, the reason I say it's not an issue is in the same way as the recycle bin on your PC typically is not an issue, or your Mac, in the sense that you pretty much ignore it until the machine comes to you and says, things are getting a bit tight on space, therefore you should consider cleaning up this antiquated stuff that's sitting in your trash can or your recycle bin. The reason it's especially not an issue in Oracle is because we don't even ask you. And let's explore what goes on here. Here's a schematic of a table space. That's the large box here. And here's table T1 that's got some data in it. Over time, we'll create table T2, and then we'll create table T3. And the recycle bin concept is very simple. It's the same way as what happens on your PC. All we do is we hide the file or hide the table and give it a special name. So when you drop table T2, it's still there. Nothing gets changed. It simply gets renamed to bin $ some big long hash string. And it gets flagged such that it doesn't appear in your typical queries of DBA tables, DBA segments, etc., etc. And we simply leave it there because when someone comes and creates the next table, T4, we'll simply use the free space in the table space and so forth, T5, etc. And this is why the table space will fill up over time. But you won't get an error. You won't get this thing on your PC saying, oh, we have insufficient space. If I go create table T6, that's what happens. We simply silently throw away the oldest recycle bin object and put it a real segment in its place. We're never going to either give you an error saying the table space is full, and we're never going to auto extend. I did the test that earlier today to see would a table space auto extend to hang on to a recycle bin object, and the answer is no. So there isn't really any issues with having a lot of objects in your recycle bin, because the database will simply flick them away, throw them away under space pressure as you create more and more stuff on there. And when you look at things like DBA free space, it caters for these things. So often the alarm bells that ring when people say, oh, my table space is full, is often perhaps due to an antiquated free space script, which is perhaps taking into account the segments where they're actually in the recycle bin itself. So in general, recycle bin objects are just a non-issue. They will effectively age out, under their own volition. However, in this case, I had to walk back my "it's not an issue" statement and say it actually is an issue. Let me explain why it was an issue for this particular person. They said, I've been doing this purge, it's been running for hours. And I said, that's really strange. I said, well, what have you got? And they said, yeah, here's our recycle bin. There are 38 million objects in this customer's recycle bin. Now, that is incredible, absolutely incredible. It absolutely blew my mind. That means over the time of this person's database, they have dropped 38 million objects. I don't know many databases that have ever had 38 million objects, maybe a million objects. I can't think of any, but obviously in this case, 38 million objects in their recycle bin. And the reality is cleanup is expensive when you get to those kind of scales. This is what I did to actually test out, to explore what happens when we actually do a purge recycle bin. I simply picked up a table space of mine called large tablespace, and I think it was 8 gig in size. I think so. And all I did was I knew that each extent we create by default in a table, in a system managed tablespace, in a system locally managed tablespace is 64K. So I could simply take the number of bytes in my tablespace divided by 64K, and that's how many tables I can create and drop without and have the tablespace full of recycle bin objects. And I simply did create table, segment creation immediate. So I definitely got one extent at least, and then drop the table straight away. So I ended up with about, did I count it? Yeah. I ended up with 130,000 tables called T that are simply 131,000 versions of the table called T, all now in the recycle bin and absolutely nothing else in the table space. So the table space is actually full of recycle bin objects. And then I thought, okay, I'm not going to take this demo out to a 38 million. 131,000 is fine. Even that took about 5 minutes to actually run that script to create them. And then I said, let's purge the recycle bin. It took 26 minutes. That's a long time. It's only 131,000 rows in that table. So obviously something's going on. And as I mentioned, cleanup is an expensive part of purging the recycle bin. I turned a trace on to see what was going on. And this is what you see down the bottom of the trace file. Even though it's 131,000 objects that are being reclaimed, the actual number of stuff, the actual number of statements being issued by the database, you can see was 4.2 million executions of recursive SQL. And you can see that's where all that time was burnt. It's expensive, like it's CPU bound, 1,271 seconds of CPU out of the 1,500 seconds elapsed time. The reason it's so heavy CPU is all these recursive queries are going to be dictionary style queries, and almost all those dictionary tables are always going to be in memory in the dictionary case. So it's very much just logical IO cranking away. But you can see a whole lot of stuff goes on when you purge your recycle bin. That was at the bottom of the trace file. Let's have a look at some of the solutions that we can consider before we actually look a bit further. The first and most obvious one is, well, if you're thinking you might get into this kind of mess, you could simply turn your recycle bin off. By default, it's turned on when you create a database. I'm not a fan of this because, with the exception of this niche case with 38 million objects, as I said, recycle bins are generally not an issue. And the best thing is, they can really save your neck if you drop the wrong table or drop the wrong object. Having that nice safety net, I think, is is well worth having a recycle bin. One of the things I explored was, well, if it takes 26 minutes to run a purge DBA recycle bin, is there any way of parallelizing this? And if you'd simply turn on parallel DML, parallel DDL, you don't really get any benefit, because it's 131,000 discrete operations, and each one does a whole lot of dictionary queries. It's not like this is a single big batch parallel operation. When I actually looked at that trace file in more detail, all a purge is doing what you would do if you were doing it manually. So for example, here are the first, 8 statements I just grepped out of the trace file that I traced to capture that 3.5 million executions. All we're doing is explicitly running Droptable Purge in the same way that we would run Droptable Purge to remove something to drop a table without it going into the recycle bin anyway. So all it's really doing is saying, take these tables, which are now called bin dollar, and just do a Droptable Purge. As you know, when you do Droptable, a whole lot of stuff goes on inside the dictionary. You have to clean up tab dollars, the internal, ind dollars, con dollars, column dollars. That's where all that recursive SQL is coming from, cleaning up the data dictionary. And so there was simply 130,000 of those, Droptable commands just sitting there in my trace file. So rather than do a single purge DBA recycle bin, I thought what I could do is I could create a table called to be purged, which is simply the owner and object name from DBA recycle bin. And I'm being a bit fast and loose here. Normally I would say, okay, where type equals table, etc. There would be a little bit more criteria here, but in this case, I know it's only 131,000 explicit table objects and nothing else. And I could assign a simple modulo sequence. So in this case, every row is going to have 0, 1, 2, or 3 as a modulo value for that sequence column. And then I could simply, in 4 discrete sessions, loop through my table for the particular sequence number. So this session would run it for x equals 0, fire up another session, run it for x equals 1, another one for x equals 2, another one for x equals 3. 4 concurrent sessions, each one doing explicit purges effectively from the recycle bin on an object by object basis, rather than doing purge DBA recycle bin. And I ran this, and you get some benefits. Like it went from 26 minutes, went from 26 minutes down to 18 minutes for each of the 4. But it does say that does prove it's not linear. It didn't become 4 times, or didn't become 1/4 as fast in each of these little worker threads. So even though we can get some benefits, one would imagine there's a lot of contention going on here, because generally we don't like a lot of people dropping objects at the same time or doing any kind of DDL at the same time. DDL is one of the less scalable things in the Oracle database, which is why we try to steer clear of it. But you can see we got some benefit. What's that? About 25% benefit. But what that tells me on my machine, and my machine's a reasonable spec, it caps out at about, I could probably clean up about 400,000 recycle bin objects per hour. What does that mean for someone with 38 million objects in their recycle bin? It's around about 90 hours to clean up the whole lot. Or what's that? About 4 days. So be aware that once you get down into this 38 million kind of category, it doesn't matter what you do, you're in for a very, very expensive time cleaning up all that mess. One of the things I would consider doing, and I've recommended to this customer, is, if you're prepared to wait that 90 hours, then fine. Be aware your server's going to be running hot while you do this as well. You might want to actually spread it out even more. But if most of the stuff in a particular table space is actually recycled in objects, and there's actually not much real segments left, it might be better to actually move those existing segments to a new table space and then just drop the old table space. Rather than having to purge out each object, you would simply say drop including contents. Still going to be very, very busy, because in the same way of dropping those tables individually, you're still doing a big dictionary cleanup. I didn't test this, but I would imagine that would be slightly more efficient. And what it does do is then have, effectively, your new table space doesn't have all this pollution in it. If you can finally get to a point where your recycle bin has been purged, and you're in a situation where there's got to be something going on here for you to get 38 million objects in your recycle bin, then longer term, you would want to clean up that mess and then have a regular job that simply says, okay, let's go, for example, you get to keep your Recyclebin objects for say 24 hours. And you can do that because one of the things in DBA Recyclebin is the drop time column. And that'll effectively, you can simply say, let's get all the stuff that was dropped more than say 24 hours ago and purge them out manually. And that way you'll never get to this point again where you've got so many millions of objects floating around in there. One of the things that does worry me, and I haven't quizzed this customer further on this, is no matter what they do, once you've got to this point where you had 38 million objects in your database, I'm a little bit concerned about the ongoing pain that they may suffer. And this is one of the things that I'm not entirely sure how we're going to resolve this. If you look at what is the indexes are on the internal table that sits underneath DBA Recyclebin, there's an index on object ID, an index on owner, index on tablespace. And this makes sense because if you look at the docs for the purge command, you can purge a single object, you can purge for a particular user, or you can purge for a tablespace. So you can see why these indexes probably make sense. If I do purge tablespace, my tablespace name, it would come in on that tablespace index to identify all the objects that need to be purged. One thing that's not there though is the drop time. As I mentioned earlier, when recycle bins are normally not an issue, as space needs to be reclaimed, I come create a new table. It simply says, I haven't got space. Let's throw away the oldest recycle bin object. It has to find the oldest object to throw away. If I've got 38 million rows in there and no index on when the object was dropped, the act of actually allocating extent or creating a new table in that table space could potentially be very, very expensive due to having to scan the recycle bin for 38 million rows to find which one to throw away. So you don't want to be getting to that point about to this point where you've got 38 million objects in there, because I think there's going to be some ongoing impacts. If you do get things like issues with creating new segments or extents and they become very, very slow, I think probably your only workaround would be to create a brand new table space and start allocating your stuff in there and just not touch this one that used to have so many objects in it, because it almost becomes like a noose around your neck. You might want to consider, okay, yep, that table space, it's just a giant mess. Let's just leave it and put stuff in a new table space because there'll be nothing in the recycle bin for it to ever be dropped out. If you can't get around with that, maybe you let's try that sentence again. If you can't do that, maybe looking at using a local managed table space with much larger uniform extent sizes, such that you don't allocate extents so frequently. Once again, trying to avoid that cost of, hey, I need a new extent. Let's go clean up the recycle bin. Oh my goodness, there's 38 million rows. And the thing that does concern me is with any piece of software, Oracle database included, there's an old saying which is like, you don't want to be a pioneer. You don't want to be the first person to ever come up with a particular set of circumstances, because the likelihood of it being encountered by lots of other customers is low. The likelihood of it being as rigorously tested because it's such a niche circumstance is also low. For example, if you have 38 million objects in your recycle bin, it means at some stage, or in fact currently, you have 38 million rows in a lot of the dictionary tables. sys.obj$, which sits underneath DBA objects. sys.tab$ sits underneath DBA tables. sys.seg$, DBA segments. If there's very few people on the planet who have over, say, 500,000 rows in these tables, if you've got 38 million rows, you're going to be the one that encounters those very strange boundary cases that have slipped through our extensive testing for the Oracle database kernel. Because I'm pretty confident that when we're building testing, we're not going, hey, what if there was tens of millions of rows in the recycle bin? Because we're not expecting that to ever happen. So as I said, it's much better to avoid getting into these circumstances rather than having to clean yourself out of them. One of the things that could be causing this, I think, and this wasn't my idea, someone mentioned this to me on Twitter when I said, wow, look at how many rows in this DBA recycle bin. They said, I'll bet it's continuous integration, continuous deployment, because you roll out a whole sequence of scripts to create your objects, do unit tests, blow it all away, roll it in, blow it away, roll in, blow it away. So If you are doing that, you probably need to be aware that you might want to add in some recycle bin purging as part of that cleanup facility, or worst case scenario, turn the recycle bin off for these things, because typically, if you're doing CI/CD, it'll probably be in a non-production database, and therefore, the ability to the desire to recover something that got accidentally dropped is much lower. So just some things to be aware of. We've got a long road ahead helping this customer with their 38 million recycling objects, because I'm not sure what's going to happen down the track, even once we've cleaned up their mess. So try to steer clear of that. Okay, Rachel, what about the cause? What are your thoughts about using recursion? Okay, about the cause, I think I've covered that. In terms of using recursion, I'm not entirely sure on your question there. Yeah, I think I demonstrated that even if we start doing multiple purging facilities, we don't get that nice linear scalability of that. Oh, Rachel said, it was old, please disregard. Much like myself, I'm old and often disregarded, even by my dog over there that's sleeping. Let us move on. Autoextend. And this was a very simple question that came in. Do you think autoextend is a good thing or a bad thing? And yeah, that's an interesting question, because I know it's DBAs in particular. We love debate, and often we can become quite stubborn. And I'd be willing to bet that probably half the people on the call are like, AutoExtend, can't live without it. Other half people have gone like, AutoExtend, you're not a real DBA if you have to rely on AutoExtend. So I thought I'd give you my thoughts and a couple of reasons why I have my thoughts. If I persuade you to change your mind, great. If not, obviously that's no drama at all. My view is yes, but. And I mean, yes, I'm in favor of AutoExtend, and I have a little but here at the end. So in the good old days, AutoExtend was easy. You had a table space. It would slowly fill up, and then once it was full, AutoExtend would simply add some space, to allow for more segments to grow. And if you had a table space consisting of multiple data files, as they filled up, it would simply pick one and extend it. Job done. The logic of AutoExtend is remarkably simple. The nice thing, or maybe the nice thing in my view, is the person who is doing the growing. So if I flip back to this slide, the person who tipped the table space over that full mark, they're the culprit. They're the person that was inserting into a table or doing something which made the table grow. They're the person that waits. The table space gets full. You've said AutoExtend of say 100 megs. That person waits for their insert to finish, because we now have to go format 100 megabytes worth of blocks on the disk. And then once that's done, that person's insert can complete. So that's both a good thing in the sense that, you made the problem, you have to wait. However, in an OLTP environment, that's also a bad thing. If you're measuring transactions in microseconds, then what happens is when you look at your pattern over the day, you got 10 microseconds, 100 microseconds, 500 microseconds. Oh, look, 12 seconds. That's not a great OLTP response time. And that 12 seconds was spent for someone waiting for my file to be formatted at another 100 megabytes of blocks, for example. So we wanted to tackle this such that people never had to wait for a tablespace to auto-extend. And we changed all this. Believe it or not, this changed way back, I think, in 9i.2, just very sort of very loosely documented, and therefore sort of went, flew under the radar. You'll see now in your database a background process called SMC0, Space Management Coordinator. And it's a process that came in, I think it was 9.2 or 10G. And there's a hidden parameter that defaults to 3, and generally we recommend just leave hidden parameters alone. And what 3 means is I'm going to, let's use the modern parlance. I'm going to use some artificial intelligence and some machine learning to actually solve the AutoExtend delay problem. What happens is as your tablespace crosses a warning threshold, even though the tablespace is not full, the database goes, let's AutoExtend in advance. Also the database, and this is where the AI comes in, if it says, okay, over the last n minutes, I've noticed a strong growth trend that suggests to me that in a short amount of time, we will fill the table space. It will also proactively auto-extend the file. In that way, when the person gets to the point where the table space would have normally been full, and therefore they would have to wait for the auto extend to happen, it's already occurred. In that way, we're sort of think of it as like the donkey chasing the carrot. We are constantly moving the table space in size such that you never ever hit the boundary. A couple of things to be aware of though is with this, when we proactively decide to auto extend, we extend all the files. So if your table space consists of lots of data files, they will all extend. So that could be a fairly hefty jump. How much do they grow by? There's a hidden another underscore parameter, which is KT text warning, which says grow the table space by 5%. Now, 5% sounds like a reasonable thing. If I cross, say, 80% full, before I get to 85, we'll make it an extra 5% larger, the table space. But that could be a lot of growth because nowadays you have things like big file table spaces. Big file table spaces. Big file table spaces are a single file that can be terabytes in size, like ridiculously large. If you have a 64 terabyte big file, then 5% is what? 3.2 terabytes of growth. That's going to be a lot of formatting blocks. Your database is going to go, oh, we've hit the 60 terabyte mark. You're heading towards 64. I'll just dip out now and format 3.2 terabytes of blocks in order for this next growth. Big files could be huge amounts of resource work in doing this auto extend in preparation for the growth. It also might be a lot of weights. Now, what do I mean by that? Let's say your 5% in this example is, say, 20 gigabytes of space. So it's not a big file table space, it's big enough. 5% is 20 gigabytes, so 10% is 40. So that's a 400 gigabyte data file. That's not out of the, that's not out of the realms of a big file size. If your table space was defined with an auto extend of 100 megabytes, just because it says 100 megabytes, the database, space management coordinator is going to go, I need to grow this by 20 gig. So it's going to go, grab 100 meg, grab 100 meg, grab 100 meg, grab 100 meg. During this time, right, there is some contention going on because after each 100 meg, we have to format those blocks. And while we're formatting those blocks, we have to do some management here to make sure that if your table space actually was going to grow into those blocks because the growth is so fast that you can't use them yet. So there's some locking going on, some serialization going on to make sure that we can't grab extents out of these formatted blocks just yet. So if you are doing this huge amount of auto extend, even though your table space isn't full yet, you might actually see some slowdowns in your transactions, which obviously is the thing we were trying to avoid in the first place. One of the things I mentioned here is you want to be careful with what I call anomalous insertion. An anomalous insertion is, as I said, we are looking at the growth rate of data in that table space. You might have a table space that grows, say, 10 megabytes every day as transactions come in, but at the end of the week, we might do some sort of summary, build some summary table, and whoop, we go from 30% to 60% full, all in one big chunk. The database is going to see that and go, oh, you've gone from 30 to 60 like this. I'd better prepare for the fact that you're going to go from 60 to 90 like that as well. And you get these big aggressive growth cycles going on. So if you have anomalous insertion, you need to be a little bit careful. And this is one of the few times where you can actually adjust these with the guidance of Oracle support. You log an SR and they'll give you the go ahead to do things like changing this enable sprees pre-allocation to 0. That simply turns it off. That reverts back to old auto extend behavior, i.e. we get full, we auto extend. And they might also give you some guidance of maybe leaving it on, but changing your KT text warning from, say, 5% down to 1%, etc. So you have some flexibility there. As always with underscore parameters, you speak to support first, but just be aware that the way of most of us think about auto extend actually changed a long time ago without a lot of us actually being told. Now, let's get back to where I said yes, but. Having said all of that, I still think auto extend is a good thing to have. And my two justifications for this. Number one is if you have auto extend turn off and you fill up, then you get an error. It's simple as that. You get unable to extend table space, the standard error. Now, DBAs will be telling me, well, if you do that, that's the DBA's fault, that's poor management, etc., etc. I take your point on all those things, but it still means it can happen. And for me, I would rather have my users go a little bit more slowly than actually have them see an error. For me, slowness trumps errors. Now, that's for me. It might not be the case. You might prefer actually to have an error, but for me, I would rather not have any errors and have them at least just go slowly. The second one is what I call full versus robustness. If I have AutoExtend, then always with the new algorithms we have, we're probably always going to have at least 5% of free space floating around in that table space. In my experience, table spaces that run close to the wire, like 96, 97, 98% full because they haven't got AutoExtend turned on, yes, they haven't had any errors, but generally full systems, in my view, generally crash more often. When you're running that close to the wire, you just get that much more risky. I did an example, I think in last month's office hours or the month before, where I showed that when you do alter table move, sometimes you need more than twice the space because of the way the database works. So you might have a 100 meg table to move, you've got 100 meg of free space, you think, yeah, that's going to be fine, but you might get an error. The moment you're starting to run very, very close to the wire in terms of fullness, I think that's generally always going to be a risk profile you'd rather stay away from. So for me, I generally like to avoid the errors and I like to avoid full systems. And that's why I prefer AutoExtend as a general rule. Okay, 9:47. Yeah, I think we might not get to the last one, but we should get to this one. Oh, I've got Q&As. I've been looking at the chat, but I haven't been looking at the Q&As. My apologies. Okay. Do you recommend small file table space or big file table space for a large table space? And why? I'm ambivalent. For me, once you get into ridiculous sizes, I generally prefer big files simply because I would like to have less files to deal with. There is a small cost for each data file you have in terms of we have to go around and checkpoint the data file headers from time to time. Therefore, if you start getting into the realm of if you had a 100 terabyte system and every file was 32 gigs, that's a lot of data files. That's a huge amount of data files. So once you start getting to those very large size systems, I would look at using big files generally. But other than that, for smaller systems, I don't have any preference either way. We monitor DBA free space and we found that these queries perform very poorly if there are items in the recycle bin, so we enforce turn it off. Is that expected behavior? No, but it is a bug. And the reason I say that is because I logged that bug. I noticed that I think it generally came in around about, I think 18. I hadn't seen it before 18, but certainly 18 and 19, I found that, yeah, effectively DBA free space queries ran very slowly when there was stuff in the recycle bin. And if you actually do an explain plan on DBA free space, you can see why it is effectively doing a nested loop through the recycle bin. So a nested loop, effectively for each row in the recycle bin, we run some very expensive query. So if you have 10 items in there, then it literally blows out by tenfold in terms of performance. There is a bug logged. One of the things that I recommend people do is when you're running it, if you're going to run a DBA free space query, then yeah, I'd look at purging a recycle bin beforehand, which obviously somewhat defeats the purpose of the recycle bin. All I can let you know is, yeah, it's basically a no. Oh, Tone has popped in. He says, yes, we've addressed the issue. It'll be additional index will be there in a newer release. There we go. So yeah, that will be a solved problem soon. Thanks, Tone, for dropping in there. Okay, tracing a single SQL statement. An AWR report shows a particular SQL as causing lots of server CPU, but we're struggling to find where in our code base it's been generated from. And generated from, I suspect, means it's a dynamically created SQL. We are considering a system-wide trace, but are there other options? And this is a common problem when we see in systems where we know, most people know that SQL Trace is this fantastic tool. It literally is the definitive performance analysis tool when you really want to dive deep. But sometimes you think, well, where do I turn it on? On what program do I turn it on? What users do I turn it on for? If you can't identify that, then sometimes you think, well, I have to turn it on system-wide. And your biggest fear is, what's that going to do to A, performance? What's it going to do to my diag destination? Is that going to get absolutely mauled, etc.? So there are worries with doing it, and sometimes people think that's our only recourse. So let's explore. Before I do that, I'm going to have two rants because Well, it's my office hours and I'm entitled to. So my two rants are, first one is instrumentation. Often when I get asked to help customers with performance issues, this is what you see. It's, oh yeah, we have a problem at the moment in our finance application, and you log on to VDollar session and you see something like this. Yep, okay, here's a SQL ID. They go, yeah, this is the problem. This is the problem session. We know there's this session's got a problem. And your job is to try and work out what's going on. And every user is called finance because it's coming through an app server. Every program is JDBC and thin client. And so you think, okay, I've narrowed down the problem now here to 1 million lines of Java code. That's not very useful. Wouldn't it be beautiful if you could simply log onto the database and query something like this, and it had, oh yes, this session here, it's active, it's the customers module, and it's a customer inquiry. I can now go to this little tiny piece of Java or Python or Node or whatever to hone in on where the performance might be. That is one of the cool things with instrumentation, and it's sitting there in the database. And this is a famous story. I honestly don't know the degree of truth in this story, but it's a famous apocryphal story that we get in the Oracle database that when early versions of Oracle 7 were being introduced, they were doing a very large benchmark, had a problem with a particular kernel routine. They couldn't narrow down where the problem was. And so over the weekend, literally Oracle developers plundered the kernel and instrumented the living daylights out of it. And that was effectively the origins of the trace data you get today. The fact that effectively an emergency session to instrument the living daylights out of the Oracle database. I don't know the degree of truth in that story, but it's certainly one that floats around. But as I said, instrumentation has literally saved the bacon of Oracle many, many, many times. And so if you can instrument your code, it will save you as well. And it's so easily and readily available. DBMS application info, you can set the module, set the action, set the client info, simple PLSQL call, job done. And once you do that, the opportunities for you as developers or DBAs become huge because you can do things like this. Here's a session that's active, and the reason it's active is because it's being blocked by someone. So session 132 is in the payroll module trying to adjust the salary, but he's being blocked by session 145. If you have good instrumentation, then session 145 might be, hey, that's Pete Johnson, the payroll admin on extension 4572. You simply jump on the phone and say, Pete, what the hell are you doing? Commit your damn transaction. Literally, instrumentation can literally make your job so much easier. And if you instrument, then finding bad SQL or the source of bad SQL is trivial. It literally just sit in the dictionary views because PLSQL has the module in it. PLSQL stats, PL active session history. All these things contain all that beautiful instrumentation code in there. It no longer becomes, here's an SQL, we don't know where it came from. You literally look in the dictionary views and it tells you because you put that instrumentation in your code. And the cool thing is you get it everywhere, not just those. Like here, I looked in DBA tab columns where the owner assists, where the column module, DBMS application info module gets stored. And literally there's 83 catalog views that store this stuff. It's stored everywhere. And people say, I'm worried about overheads when it comes to instrumentation. Well, let's create a little package that calls DBMS application info and run it 10 million times. And it works out on my machine here, I can call DBMS application info, even though it's wrapped inside my own custom package, about 1.23 million times per second. Rest assured, instrumentation costs you nothing and the benefits are massive. And people say, but we don't use PLSQL. Doesn't matter. You can set the modular action as part of your connection, whether it be .NET, Java, etc. All this stuff is available. Second rant, seeing as people said we don't use PLSQL, if you put your SQL in PLSQL, this also becomes a no-brainer. If you have your SQL in PLSQL, the task is done. And let me give you a little demo of that. Flush out my shared pool. I'm looking for any SQL that says select special column from. There's none in there because I haven't run it yet. Create a table called T, put one row in there. There's my query. Select special col from McDonald.T. And if I query VDollar I can see it's now in the library cache. And it shows me, what do I get? Well, it says it came from SQL Plus. That's sort of useful. There's no action. tells me the service, here's a SQL ID, but that's about it. In terms of identification, this is a SQL that hasn't come from PLSQL. Really, all I can do is SQL Plus put the module in there for me, luckily. If it was a Java application, it would probably just say JDBC thin client. And it tells me, oh, the parsing user ID was 107, that's me. But even that, I really can't rely on, because if that query, that table is available to anyone in the public space, I reconnect as Scott and query it. Guess what? Now it says it was 195 that parsed the query. So if I'm using the parsing user ID in lieu of anything else to try and find out whereabouts in the code base it is, that's not really going to help me if it's just plain old SQL coming from a program like SQL Plus or Java, whatever, because whoever last parsed it is going to be stored in there. Compare that to this. Flush everything out of the shared pool so it's not in there anymore. Let's put it in a PLSQL routine. So simply looping through that, it's in, this could be opening a ref cursor. In this case, I'm just looping through it. Run the routine. Now, when I look for that query in the shared pool, guess what? It says, here's your query. By the way, it came from program number 92209 on line 3. What's 92209? It's simply, it gives you the name of the procedure from DBA objects or user objects. So any SQL that's in a PLSQL program, it'll tell you what PLSQL program it came from, and it'll even tell you the line number that the thing was run from. It's literally that easy to find a SQL statement. If it's a problem one, you just simply look it up in VDOL or SQL, job done. Even if, let's flush out the shared pool, it's gone, even if it's dynamic SQL. So this is PLSQL running dynamic SQL. Run the procedure, it still is in there. This I'm on line 5. So any SQL that's issued from PLSQL, it's going to be tracked within the PLSQL module so easily. Anyway, that's enough ranting. Let's go back to the slides. Put it in PLSQL, the job is done. Let's go back to tracing. The supported mechanisms for tracing are generally DBMS monitor, which you can turn on session tracing for you can turn on tracing for a particular session. You can turn on tracing for a particular client ID, which once again means you need to be doing some instrumentation, or you can turn it on for a combination of service, module, and action. They're the supported mechanisms for actually turning this thing on. Once again, they're all useful, but they're really relying on you having done some instrumentation yourself, because if you have none, then which service do you turn it on for, which module, etc. You're back to this problem of, do I turn it on for everything and have that much trace data? So let's tinker very slightly with unsupported mechanisms. 9:59. We might run a few minutes over here. So this is one way of doing it at system level. And this is, even though this is commonplace, it officially is unsupported. You older system set events 10046, which is SQL Trace, turn it on system-wide, and then use grep for your SQL. That's not a great way of doing it, but that's one of the unsupported mechanisms. But that's the one that people are most familiar with. But the reason I wanted to touch on unsupported mechanisms was we actually revamped the entire event mechanism way back in Oracle 11. We just didn't document it because none of this stuff is documented. You can do something like this. Alter system, set events. I want to do a SQL trace for this particular SQL ID. And when you see it, get the plan statistics, capture the weights, capture the binds. That's all on a single line, just I couldn't fit it on the slide. But how cool is this? System-wide, I've turned on a trace, but I'm only going to pick up this particular SQL statement if it occurs, rather than dumping that trace everywhere. Let's do a quick demo of that. You can see it's actually this select special call is that particular SQL ID that we're going to trace. So flush out the share pool, it's no longer there. Here is my alter system set events, turn on just for this particular SQL and capture the various bits and pieces. I do a select count star from DBA objects. That's not going to get called because it's not my SQL. Select count star from T, there's my special statement, and there's another different variant. A normal trace would collect all of those. Let's see what happens. So I've turned off my trace. Here is my trace file. I have to disconnect because Windows won't close my trace file until I disconnect, and fire up. What's in my trace file? The cool thing is it picks up the recursive SQLs that were fired as a result of that SQL. The reason that's cool is if your query did dynamic sampling, for example, which can be very expensive, it'll be picked up. But if we scroll down, if I go right down to the end, you can see the only SQL besides the recursive ones was, oh, you probably can't see this window. Silly me. Let's try that. Okay, let's try again. Here's my trace file. It has all the recursive SQLs in it that were fired as part of this overriding SQL. That's very useful because it picks up dynamic sampling, which can be expensive. But if I scroll down to the end, we can see it only picked up the particular SQL ID that I was interested in, this one. It didn't pick up the other 4 I ran. It just picked up this one. So it's selectively tracing just a particular SQL. So that's super cool. Using that syntax, and I'll put this on a blog post or something, you can actually now trace just a single SQL statement. Now, you might be wondering, what on earth, where's all this stuff come from? Right? Well, I did mention it's unsupported, so it's not in the documentation, so you're not going to get it. But some really, really cool references for how you can dig into this from Cyan. I hope you pronounce your name right, Cyan. He's got a great blog post, and Tanel Poda, 2 fantastic references here in terms of getting an idea of what you can access. Oh, did I put? Oh, yeah, I forgot a demo. I said, yeah, what the hell? We have one last demo. Should we do the demo? 10:02. Maybe we should skip the demo. Maybe we should wrap it up. Yeah. Right. Okay, let's do this last demo. This will blow your mind. Okay. Last demo. I can see the numbers dwindling on the attendees, but that's okay. So the question is, how do we dig into all this stuff? Let's connect as sysadmin. All this stuff comes from a thing called AuraDebug document. And this is how we document some of the internal stuff inside the Oracle database. So if I run AuraDebug doc, someone's got a question here. If I run AuraDebug doc, it says, yep, you can do debugging on events or components. So let's start with events. Now, the reason I've put this out in little plus signs here is I'm about to run this command, but it scrolls a lot. So I thought I'd show what the command is so we'd actually see it, and it flies through. So if I scroll back, you can see it's way back here. It says, doc event says you do an event spec, etc. And it gives you some samples of how to set events, etc. But it also says what it really is an event consists of a name, a scope, a filter, and an action. So let's drill into that. AuraDebug doc event name, and these are the names of things that you can set events for. And if we look, one of them, for example, is SQL Trace. That's our SQL Trace event. We can also do trace, and you can see a whole lot of other stuff, huge amounts of stuff. So I said SQL Trace, let's do Aura doc event name SQL Trace. And it says, if you do a SQL Trace, these are the facilities that you get access to. You can ask for weights, binds, plan stat, or level. So by working our way down this event hierarchy, sorry, let's try that in English. By working our way down this event hierarchy, we've now seen where this syntax came from. It said, if you're using a SQL Trace event name, then these are the things you can add to it. You can ask for plan stat, weights, etc. You can ask for various things that tells you what you can do. So this explains how this command is built. It hasn't explained how if we're allowed to put this SQL ID in, but let's continue. Let's do Aura doc event scope. Scope says inside the event scope, you can do a SQL or a queue. And what do we do for a SQL? It says for a SQL, you have to nominate a SQL ID. And so that explains where the rest of it comes from. This is the event name. These are the facilities available to the event name. And this is the scope qualifier to actually narrow that scope down to just a particular SQL. There's also extra filters. So these are all the filters you can do for these various things. I can, for example, say I want to filter only the third occurrence of this execution of this SQL statement. I want to filter on, say, a particular weight. So let's have a look at that. If I want to filter on a weight, it says yes. I could trace an SQL, but only capture the information if a weight exceeds a certain amount of time, for example, or P1, for example, if it's a file read event, P1 is the file. I can filter on that as well. I can filter on a process. So I could say, I only want to filter if it comes from a particular operating system process ID. If I know a particular program on a particular session is doing it, program name, particular container, all sorts of goodies. event actions. Event actions are massive. There's just go on and on. These are all the things I want you to do when one of these events is found and triggered. So I can say, for example, I want to, when the event action is a query block dump, it'll tell me, yep, the parameters for that are you pass in a level, the level is default 1. So with all that, I could, for example, well, then we get into components. I'm going to fly past that. I could then do things like this. I want to do a SQL trace as we saw before. Here's my scope. Here are the actions available for this particular event. But I could also do things like this. I want to get a trace of this component, the SQL optimizer, for this particular SQL ID. And when I get it, I want to do a query block dump at level 1, what we just saw. So there's this huge infrastructure of incredible power and incredibly complicated stuff that you can do. But as I said, did I mention this is unsupported? If you want to tinker with that kind of stuff, for the love of all that is holy, do not do this on production if you don't know what you're doing. All this stuff is really to be engaged with by Oracle support in emergency situations. Probably SQL Trace is the one exception. If you want to go in there and start saying, okay, yes, let's find a particular SQL statement. And when I find it, let's corrupt my control file. Guess what? That's going to end very badly for you and your database. So there's a huge amount of power in there, but generally these things are undocumented for a reason because they're really meant to be used only under the supervision of Oracle support. But just so you understand where this new syntax is coming from, there's some facilities there that let you actually explore and go a bit further for that kind of stuff. Now, we did have one more topic, but as I said, I always run out of time. So all I'll say is see you next time. Thank you once again for your attendance. Thank you for staying with me 8 minutes past our allotted time. I hope you enjoyed this session. I'll put the last one, UTL file do migration, back on the topic for next month. Love doing this office hours session. I hope you enjoyed the content we had today. It'll be up on video as per normal. Until now, thank you always for your time. Hope you enjoyed it, and I'll see you next month. Please stay safe. Please stay healthy. Get vaccinated, and we'll be face-to-face hopefully sometime soon. Good night, everybody. Have a great rest of your day, morning, evening, etc.